Now we're going to talk about what is probably the most frequently seen or the most common famous equation in physics, which is E is equal to delta mc squared. Now many people forget the delta m, but the delta is very, very important, because if we write m, then it gives a sense of being the mass, but it's actually not the mass, it's the mass defect. So we all know that Einstein gave this equation, E is equal to delta mc squared, and this is an extremely revolutionary, path-breaking equation. It basically tells us whenever there is a loss of mass, it generates energy, and whenever there is energy, energy is capable of creating mass. So energy and mass are actually interrelated. They can create one another. Now, what exactly is mass defect? To understand what the delta m in the equation is, we know E is the energy and c is speed of light. We are going to consider this simple example. Say I have a nucleus that has got 2 neutrons and 2 protons, and I'm measuring the mass of these 2 neutrons and the mass of these 2 protons separately. Mp is the mass of the protons, Mn is the mass of the neutrons, M capital N is the mass of this nucleus. What I'm going to find out once I calculate this is that the mass of the nucleus is lesser as compared to the addition of the individual masses of the neutrons and the protons, which means that when neutrons and protons come together to form a nucleus, they are actually going to be losing mass. Now, what is the implication of this loss of mass is what we're going to discuss in another video, but right now it's important for us to understand what this E is equal to m delta mc squared actually implies. So delta m is nothing but mass of protons plus mass of neutrons minus mass of the nucleus. That is the mass defect. And because there is a reduction in the mass, what is going to happen is that energy is going to be generated. The lost mass expresses itself in the form of energy or releases energy. And that is basically what Einstein proposed when he proposed this particular equation.